Students, the term we have, that is theories of the normalization. Since doing the normalization on the database is not an easy task. Why? Because in our life we have the two different flavors of the database, and that could be recognized by as a bad database or good database. So you have a database that it may have, you can have the database in form of the bad form. How to identify the database as a bad form? The simple term or simple concept: your database can have the duplicate record or redundancy. Your database can have the inconsistency form of the data. Your database is not in the simplification, it can have the various kind of the anomalies. Okay, so such kind of things or such kind of the form of the database followed by the base database. So normalization is a process, actually you can say normalization is process or method by which we can normalize the data, or we can say we can simplify the data in a simple way. So normalization is a method of the organizing the data in the database, which helps you to avoid the redundancy, insertion, update, deletion anomalies. So what is meant by the anomaly? So I will tell you the example with some good example, then you can understand the term about the insertion anomaly, update anomaly, and deletion anomaly. It is a process of the analyzing the relation schema based on their different functional dependency and the primary key. Now here we have the term that is the functional dependencies and primary key. So what is mean by the primary key we have seen, but when talking about the functional dependency, so I will tell you more detail about the functional dependency with the real example, then you can understand the such concept. So normalization is inherent to relational database theory. It may have the effect of duplicating the same data within the database, which may result the creation of the additional tables. So you are performing the normalization means you are changing your bad database into the good database. So this is the point. This is the key point from which we need to understand the normalization term. So before jumping the normalization or before performing the normalization on our database, let us understand the few important terms, and those are necessary part. So in today's class, we will see the prerequisites of the normalization. We are truly speaking. Okay, to directly performing on the normalization operation or anything, it is understand the basic term about the or prerequisites about the normalizations. So I am going to start my first slide. That is, you can see over here. We have the very important points here. We have the various relations. From this point, you can start all the concept properly. So there are many type of the normalized form of the existing in the database environment. So those are the first normal form, second normal form, third normal form, BCNF, that is the policy code normal form, fourth normal form, that is also known as a multi-valued attribute normal form, and we have the fifth normal form. This is also known as a PZM, that is a projection normal form. By default, the database we have that is in form of the first normal form. So normal form means we have the data into simplification form, that is a basic level we have the first normal form. But why the second form normal form is required? What third normal form is required? So with the practical, with the help of the practical by or with some real example, we will understand this concept one by one. So what is the need of the normalization? As I told you, need of the normalization means to simplify the data or to change the data from good database a bit bad database to good database. So I can write over here to change that your information from bad database to, or you can say uh, bad database to good database. Now let me know what is mean by the bad database and good database. Just we need to change bad database to good database. So if you're looking for bad database to good database, so what are the various properties of the bad database? Of course, we know a bad database can have a duplicate. Okay, so this duplicacy you can understand why the duplicacy, or this can be understood by the redundancy. And now next we have the inconsistency. So this is a need of the normalization. Okay. Now, is it clear to all about the what is the need of the normalization? Please tell me. Any
Yes.
doubt? Okay, so why we are understanding this concept? Now it is clear to all why we are understanding this concept. Okay. Yes. Any doubt over here? Please, you can ask me. You have any doubt?
No, sir.
Okay. So normalization the need you can understand to reduce the redundancy, as I told you. So we will study normalization further to reduce the redundancy. No inconsistency should be, and no loss of the information from the database over the lifetime of database. This is the most important part. If we are having the normalization, so we need to keep in mind data should not be lost. And why data can be lost due to the performing the many operation depend on the what kind of the operation we are having. So we will see what are the various category of the decomposition. So while decomposing the database or doing performing any operation, it may some chance data may loss. So that part is also known as the decomposition of the database. So it is divided into two different part, that is a lossless database or lossy database. So after decomposing, if I'm losing some data, so we have the lossy database. So that is also part of the important part of the normalization. So the need of the normalization is more important part. So here I'm taking real example of the student relation. So what are the various attribute of the student relation? And you can see over here the roll number, name, course, phone number, major. Major means we are talking about the subjects, what the subject is taken by the student. And professor we have means the faculty who is associated with the students. And the grade. Okay, how many grades or what the grade is just having by the student. If he just face the examination. So after the examination, what is the result he or she has. So here we have the point. So keep in mind what we need to look into the our class, that is the student relation we will see, and this relation we will see entire detail. So what is a different constraint for creating database? So student roll number should be unique. So this is the point we need to keep in mind, that is a student roll number can be a primary key. So a student can join many courses. Of course, it is also possible. So a student can join the many courses. A particular student has a single phone number and major. Okay, so a student can join the many courses, but student can have a single phone number, and it can also the major. And major means we can say it is talking about the degree. So it could be any degree like BTech, MTech, and so on. So a course is taught by the only the one professor. So this is the point we need to keep in mind. So one faculty will be course having the one course. So student is associated only the one faculty at that time for such course, and one grade is given to the student for the particular course. So in such a course, what he how she got. So this is the point. So different constant we need to keep in mind, and this constant can be varied according to your requirement. But we are taking this example, so we need to keep in mind the some constant, and what are those constant while creating the this relation we need to keep in mind. So constant can be more advanced or more effective while restrict the design to the database management system. So this is the point we need to keep in mind. If you're putting the constant, then we need to restrict the design of the database. So while restricting the design of the database, here we need to see how we can restrict. So here we have the this example. So a relational state, you can see name we have, the course we have, the phone number, major, and a professor, and a grade or she has. So you can see there are 1, 2, 3, 4, 5, 6, 7 tuples we have. Okay, in this 7 tuples, student name is associated with the simple over we have the name, course, what is the course he is opted by, and his phone number, and his major means what is the subjects he or the stream he or she belong to. It's computer science, chemical, and physics and also. And who is the professor who is associated with the such student? So he it is written name is written over here, that is Rajat, Bharat, and Siam, and so on. So, and what the student got the grade A, B, B in PR and C. Okay, in PR, what is mean by the in PR grade? Yes, student, can you tell me what is mean by the in PR grade? ABC is okay, we can understand. What is mean by the in PR grade?
In progress, I think.
Yeah, of course.
In
Yes,
progress.
yes, good, good. It is right. In PR means the grade is in progress. So this is a relational we have. Now keep in mind we have not introduced the student roll number over here. Okay, what the information we have over here, what is the name, codes, phone number, major, professor details, and professor details means professor name only and the grade. Now, so the instance in which the database is currently, so there will be some instance on which the database is created. Okay, so the moment on which the database is created. So this is the mom of the relation we have over here, that is student relation. So the instance on which the database is created means on which moment the database information to be entered or updated and so on. So from this point we need to learn the important part. Now I'm just moving to my next slide. Now you can see here. So what is the problem? That is the redundancy. Then update anomaly and insertion anomaly and deletion anomaly. So from this point, we need to see what is the drawback or what is the pitfalls we have found in our database. So this database is good or bad, and how you can justify this is a bad database or good database. So I'm just moving to back to the my slide, and just please let me know what is the pitfalls we are finding in this relation. Just please, any student can tell me what is the pitfalls we are having, or what is the how you can justify this is a good database or bad relation or good relation.
So here, if we consider there is no primary key to distinguish between data sets, and secondly, we can see that there is redundancy. Maybe a student may have same name, but Rohit are coming two times with same phone number. So this we can make a relational relation between two tables, but here Rohit is coming two times, so with different courses.
Yeah,
So,
yes,
in the prerequisite, it is given that only a student can have only one course.
yes, of course. This is the point. Your observation is appreciable. So I appreciate your observation. What you have observed here. So let me give you more detail with the proper way to other student as well. The if the other student have been observed the proper way, it is good. So it is clearly showing over here. They were talking about the problem. So the problems we are talking about the problems. So redundancy, update anomaly, insertion anomaly, and deletion anomaly. So can anyone tell me about what is mean by the anomalies word? Anomaly. What is mean by the anomaly? I'm saying insertion anomaly. So what does it mean? Insertion anomaly. Since in any subject, if you're understanding the words we have, the word should be clear. The word is clear, then we can understand the concept. So what is mean by the anomaly?
Irregularity, sir.
Something that is not expected.
Irregularity, it is good synonym we can say for the anomaly. Irregularity, issue, problem, these are the terms which can be understood by the anomaly. So insert an anomaly, you can understand the information is already inserted. If you try to insert same information, so we are making the duplicacy. So this is the insertion anomaly. So okay, we will see this concept one by one. So the problem should be in proper way. So what is redundancy, what is update anomaly, insertion and deletion? Okay, so far everything is clear to all. Just before moving to the my next slide, just let me know everything is clear to all. Why we are understanding the normalization, what is the field or
Yes,
attribute of the relation? Any doubt so far?
no doubt, sir.
Okay, so I'm moving to the my next slide. You can see over here the student redundancy we have. So you can see from my slide over here the yellow color, the Rohit name was here three times, and his details are three times we have. Okay, you can see over here the phone number and his major subjects. Okay, it's computer science, computer. So we have the duplicacy of data. You can see over here. Can we say here we have the duplicacy of the data? Without the primary key. So without the primary key, it is showing that we have the duplicate record.
Yes, sir.
Yes. Is it clear to all?
Yes,
Yes,
sir.
sir.
Yes. Any doubt? Any student who have any problem over here to understand the redundancy of data? Redundancy of data means the redundancy or duplicacy of data we have in this relation. So how you can justify, how you can say we have the unique record, so we don't have, because it was our constant and a record or student details must be unique. So there's a one field by which we can identify that's a student number. So but this time we have not introduced or we have not put it the student roll number as a primary key or uniqueness purpose. But if you're looking for the student name, then you can see the Rohit was the three times name over here. So we have the duplicacy of the desired. So this is was the first problem. So in our database or in our relation or table, we have a duplicacy record or duplicacy of the record. So what is the problem? This is a problem. So to avoid the such problem, we have to normalize the information. So before jumping to normalization, it is better idea to understand the some prerequisites term. So here we have the first problem, that is the redundancy. Is it clear to all about the what is mean by the redundancy of the data with the visual way? It is clear to all? Just please tell me any doubt if you are having. No doubt. Now shall I? Okay. So now, again, if I'm not looking for the only name, if I'm looking for the other details, like what is the detail? We have the course. So on the course, you can see CS303 is coming three times, and it is associated with the professor. So professor name is also associated with the same course again. So we have the duplicacy of the data. So this is another point we have found. So you are not looking for only the duplicacy of record in a single attribute. We can say that in the multiple attribute, we have also the duplicacy of the record. So this was the problem. Now, now you can see the update anomalies. What is update anomaly? You can see over here. Yes, after seeing this slide, what you are thinking? What is mean by the update anomaly? Anyone? Yes, please. Any student who want to explain the concept
Sir,
about the
update anomaly is basically means inconsistency in data. Like we have three copies of data, but when it comes for in times of updating, only two copies updated and third copy is not updated. Just like catch inconsistency.
okay?
So this is update anomaly, sir, where
This is
all copies of data is not updated.
okay. I agree this point, and this is good point. Since we need to update the phone number of the Rohit, 696455269645 but we are not known to the Rohit name, so we have to update the phone number which is given over here 696455. We update this phone number, so all the phone number which belong to same value will be updated. So why we are updating the other thing? So this is the point. This is the update anomaly. So while updating the information, of course, this is the point we need to keep in mind. May the only one information may update or other information may update. So update anomaly means we have the updating the information. We don't know which tuple or which information to be updated, because now you can see student name is Rohit, but phone number is already given here and professor is Rajat at that time. But you can see Rohit is also here and professor also Rajat, but you can see about the grade. From this point, you can see he got the A grade. From this point, he got the B grade in different course. But when we need to update the phone number, definitely all the phone number will be updated. So how you can identify which tuple we need to update, which information we need to update? So at the time the update anomalies, we have the duplicate, we have this problem irregularity. So to avoid the this kind of irregularity or problem or issues, we have the point. If I'm talking about another anomaly, you can see that is an insertion anomaly. If I'm inserting a new record, that is with the help of the CS500 course ID, with the professor followed by the professor name, that is Bizay. So if I'm trying to insert, there may how maybe some chance this record may already exist. So duplicacy is available in easy way, and duplicacy are also welcomed in our relation without any problem. So this is the insertion anomaly. If we're talking about the deletion anomaly, suppose I am deleting this record that is a Martin who belong to the CS5J3. Maybe while deleting this record, while maybe deleting while deleting this record, the all the records which belong to Martin may be deleted. So while updating, inserting, or deleting any information, the information which is not belong to the actual actual point or matching point, so it may update or delete or insert. So we can say this is due to this anomaly, the wrong information may be updated, wrong information may be inserted, or wrong information may be deleted. So due to avoiding such things, we have to use normalizations. Normalization is simple word, you can say simplification or simplify your database. So when we have the information which need to update, suppose I want to delete the record who belong to the Martin student. So what happened at that time? Maybe Martin CS503 or the professor belong to the Siam. This may be deleted, but I want to delete the professor who belong to the Bharat. So I need to specify the condition that is okay, you can do. But this record is deleted, which is not unwanted record is deleted. So why we are doing? So why while performing any operation in the database like insertion, operation, or deletion, or we can say these are the DML operation. So after performing DML operations, definitely what happened at that time, some anomalies or some irregularities or problems or issues may occur. So to avoid the such thing or to prevent from the such things, we have to normalize the data, and we need to transform our data from good database or good relation to the bad relation to the good relation. So transformation is necessary part. So this is a need of the normalization. Yes, here in these three different kinds of anomalies or four different issues we have, the redundancy, update anomalies, insertion anomalies, and deletion anomalies. Here, yes, student, please tell me any doubt in these four different problems, and these four problems justify the need of the normalization. Yes, please tell me any doubt from this point. Yes, student, any problem over here? You can ask me. Yes, any doubt?
No doubt, sir.
No doubt. Everything
No,
is clear. Is it clear to all about all these anomalies and redundancy problem? So what we have the problem? Okay. Now shall we move to the next slide?
Yes, sir.
So we have the functional dependency. Before normalizing your relation, we need to see the important aspect of the database, that is the functional dependency. Functional dependency or functional dependence means it is constant on the legal relations. What does it mean, the legal relation? It means the functional dependency will perform on the actual relations what we have. Okay, this is theoretical as well the practical, or as well as the real implication we can do. So FD are the constant on the legal relations. It express fact about the enterprise that we are modeling with the database. So it will work with the real database. So you can say now we have the student relation, faculty relation, and course relation. So we know this point, course is depend okay, student is depend on the course relation, and faculties also depend on the course. So some information is depend on the another or some relation is depend on the another relation. So something will be depend on the each other. So that's why we have the dependency. So when talking about the dependency, so how the dependency will functionize in a table, and that is concept we will start from the functional dependency. If you're not understanding this point, or you are directly jumping on the normalization, then a term will come into the our various kind of normal form, that is functional dependency. So it is our responsibility to understand the functional dependency concept before understanding the more detail about the normalization. So these are prerequisites terms or prerequisites statements, or the point where we need to start the functional dependency. So here we have the term that is a functional dependency. So now identify the functional dependency. So here you can see there is a no algorithmic method of the identify the dependency. We have to use our common sense and judgment to specify the dependencies. So here you have to use brain and mind to identify the dependency. So dependency means you need to identify what attribute depend on the other attributes. So at the time you have to use your brain or logic. So the logic implication is more important part over here. So how you implement your logic here, this is necessary term. So functional dependency is there is no algorithm, there is no method. Okay, there is no method or no specific algorithm. Only we have the certain rules on which we need to follow the specific task. But while performing the task, we have to think which attribute is depend on the other attribute. Now you are depend on the course. You are depend on the course means students depend on the course. So there is some dependency between the course and students, so we can say. And the students are depend on the faculty, there's no guarantee, maybe or may not, because you are not depend on me, but truly speaking. Okay, if I'm not offering this course, then you can you may associate with the other faculty as well. So you are depend on the faculty, but you are not dependent on the individual faculty. So there will be the big dependencies or strong dependencies. So you are here, you have to use the logic, and with the help of the some example you will understand all those points. So functional dependency is more important part for the normalization purpose. And here this is again I'm speaking to all, this is the most important part of the database. From we need to do the real operation, because real operations means you have to identify what thing is depend on the thing. So in any way you are looking for the shopkeeper is depend on the customer. If shopkeeper is open a shop and no customer is visiting his or her shop, then what is the opening of this shop? No. So shopkeepers depend on the customers. Okay, so this is the point we need to identify with the real life applications. So and customers depend on the shopkeeper's product, so customers depend on the product rather than the shopkeeper. If I have the good relation with the shopkeeper, so I can visit his or her shop without any problem. But I am dependent on the product, I need the such product, like I'm looking for the good mobile or a mobile of any company, but the shopkeeper is not selling such mobile, so I'm not depend on the such shopkeeper. I will be depend on the product. So what is the dependency I'm having? This is the point. From this point we need to start the functional dependency. So here, yes, tell me, this point is clear to all, what is mean by the functional dependency, and how to start the functional dependency we will see. But any doubt here to understand a little bit idea about the functional dependency? And in the functional dependency we're looking for the database or relation or table. Then we will see all the concept by its important part or component of the relation, that is known as a attribute. So attribute is the most important part on which we will start the functional dependency. But I told you the information by some example, that is the customer, product, and shopkeeper. Okay, yes, please tell me any doubt. Yes, from
No
this.
doubt, sir.
Okay, so is it clear to
No
all about
doubt,
the
sir.
okay, is it clear to all about the dependency? Dependency means where we need to look for the dependency. And this functional dependency will take approx 3 classes to complete the all the concept, because I have the some exercise on this functional dependency, then we will see. So that's why I'm saying to all, this week and next week we will cover some important parts that will be followed by the normalization. So normalize is not be complete within the 2 days, 3 days, or one class of 2 class, 4 class, 5 class. It takes some times to understand all the concept properly. So that's why I have started the normalization from the very beginning part, that is what is mean by the normalization, why we are going through normalization, and what is the problem we will face into the bad database. So we need to transform bad to good database, it is our responsibility. And what is the functional dependency? So we have the some term over here. So now see the next slide, the dependency diagram. So name, we have the phone and major. So and course is followed by the professors, yes. And key attributes we have, that is two key attribute in our relation, that is a name and course. Yes, anyone can tell me or can just elaborate your idea after seeing this slide or this diagram? What is the sense of this diagram? Yes, please tell me. Okay, what is the sense of this diagram, please?
Here we are seeing that there are two entities, name and course, and
No, 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 no,
associated
no.
attributes.
Oh, my dear. This you are still just confusion. Entity means entity is equal to the relation or table in your model. Here we have the two attributes, name and course. It is written over here the key attributes. So the words, while speaking anything, just please remember the words. These are the no two entities. These are the two attributes of of an entity, that is the student entity. Okay.
Okay. तो
Okay.
सर
So what
attributes
exactly
attributes
is the
connect कर दिया अपन ने.
I agree this point, but entity, relation, table, all are having the same sense. So here we can say the entity name is student, and it has the attributes. Those are the name, course, phone, major, grade, and professor. So we need to see this diagram, and here I need the answer from your side. What is the sense of this diagram? And it shows us some dependency. So can you elaborate your idea after seeing this slide? This is my point.
So
Is name?
like in this diagram we connected attributes as we know that if we have a name then if I have a name of any student then it is related to the then I have also the student phone number. Same as if I have a course then this course is provided by some professor. So I connected course with a professor such like that.
Yes, I agree this point. No problem. Just let me explain very simple way so you can understand. Now, I'm starting from the very beginning part, that is a name. Name we have. We can say I'm just putting this arrow to explain this concept like this point. I'm just writing this diagram only this way, and I can broke or I can break this point like this one. Major means we are talking about the stream of subject.
Degree.
Okay, this point please keep in mind. So name is an attribute, and major is an attribute, and phone number is attribute. Now agree this point. Yes, please tell me. Name, phone, major, grade, professor, course. These are attributes. Can I say? Or we have.
Yes, yes, sir.
Okay. So if I read this statement in simple way, phone number is depend on the name of the student, and major is depend on the student. Can I say? Because if the student name does not exist into the relation, then how you can say, or how you can find the name and the number of the such student? So this is an attribute which is depend on the other attribute. Can we say? Can we say?
Please repeat, sir. What?
Here I am saying to all here the important words, that is name we have, and phone we have, major we have. These are the various attributes. So phone is an attribute which is depend on the student name. Suppose student name detail is not entered into the student relation, then what is the sense of putting the phone number? So this attribute depend on the student name, and major depend on the student name, because who have opted the computer science, chemical, biotechnology, electrical. So how you can identify? So name is an attribute which determinant to the phone or major. Or we can write this statement like phone is depend on the name and major is depend on the name. So we can say the major attribute or phone attribute are depend on the name attribute. Can we say? And
Yes, sir.
course is determinant to the professor, or we can say the professor is depend on the course. So this is an important point. So I have if I need to offer the some course, so I need the list of the courses. Okay, so I'm depend on the course, which course I should offer. So we can say this is a point. So is it clear to all right now?
Yes, sir.
So this is a professor is, if we are reading this statement from right to left or left to right, so here we have the important term. Just let me clear right now, so for the coming classes this will be clear to all, and in the coming classes we have the other terms, so I will explain one by one and in specific manner. See, course is determinant to professor. So if we read this statement from left to right, so we have determinant. Okay, this is known as the determinant. So we read this statement, course is determinant to professor. If you're reading from right to left, this is known as the professor is depend on the course. So arrow is known as the dependent. Now tell me, this dependency diagram is clear to all?
Yes, sir.
So if there is a relation, if I am speaking by mouse, then you can understand you are a customer, and we have the customer relation and we have the product relation. So product is depend on the customer, or customer depend on the product?
Product depends on customer, sir.
Product depend on the customer, customer depend on the product?
So product depends on customer. Customer has various choice, but if customer is not there, then what is the use of product?
Okay, this is the point. So here, from which direction you're reading the point, that is depend on your point. So that could be one point, or determinant or dependent, and we will see all these concepts with another example. But here we need to understand the important point over here. So course is determinant, the professor, or we can say the professor is depend on the course. And now you can say this arrow is more important while learning the mathematical rule. So in the database you have seen the uh, some mathematical formation of the information. So in the computer science we are studying any subject, so mathematical is more important part. So here we need to understand very beginning terms, that is determinant and dependent. Okay, so I can I move to my next slide, if it is clear to
Yes,
all? If it is clear to all, yes, can I switch?
yes, sir.
Okay.
Yes, sir.
Okay, from this point I have the written material about the functional dependency. Okay, so that's why I have the scanned material of limited page. Actually I have the more than approx 150 pages of the scanned material of the DBMS. But in the my laptop I found I have the only the 60 or 60 20 70 pages around. So few pages are not scanned by myself, but those pages who have been scanned by myself into the my written way. So I just put it as in form of the image over here rather than typing or something over here. From these notes or from this PPT, when you see all the details note, so you can go through all this PPT and you will find the some part of the scan material about the this concept. So here I have the image. Okay, this is my handwritten images over here. Written handwritten notes which is in form of the scan way. So I have written over here. So you can see over here there's a functional dependency. It is a particular kind of the constant. Okay, and I'm very extremely about this even I have the personal constraint about the handwriting, so you have to avoid the bad handwriting. Just you need to look for the concept only. So functional dependency, we have the some important points. So those are, it is a particular kind of the constraint we have to keep in mind. The notion of the functional dependency is a generalization of the notion of the key. Okay, of the notion of the key is means what is the key attribute we have. So from this point we have to keep in mind. So now see in the dependency diagram, name is determinant to the phone and measure. Okay, so we can say generalization. Then generalization and specialization we have already seen, that is in form of the is relation. So we can say if you remember into the ER model, so we have the is a relation. So is a relation is showing that one one entity is a part of the another entity. So that's why this is a generalization is showing that one attribute is a part of the another attribute. So this generalization what is showing over here, one attribute one attribute a1 is a attribute is a part of the another attribute, we can say. So a2 is depend on the another attribute. So this is generalization means, so we can say a1 is a part of the a2. So I can write in this statement a1 is a part of a2. So suppose we are looking this statement, so we can say a1 and a2 are following the concept of the generalization in simple way, but it has a functional dependency. It means there's some functionality of the a1 attribute depend on the a2, or maybe the a2 is depend on the a1. So depend on the your writing way from which direction you are putting the a1 or a2. So functional dependency play important role in the database. Okay, so now it is clear to all what is mean by the generalization word I have written over here. Yes, please let me know. It is clear to all?
Yes, sir.
Okay, so here mathematically we will see some concepts and you will see and understand the point. And this all the concept, all the notes is taken from the Henry of Course book, which is standard book, and this is the best book for understanding the functional dependency. So for understanding the normal form, normalization and functional dependency, please go through the Henry of Course book of the DBMS. I have already shared such ebook of on the Google Classroom, and from that place you can collect the book or download the book and see the notes. So same notes I'm just sharing with all into my handwritten space, so you can see here. So let R be a relation schema and subset K of the R is a super key of the R. Now, what is a super key? We have seen super key is also a key which define the uniqueness of
Combination
your.
of primary keys.
Yes, different, good. So we have seen the all the keys. Those are the super key, identity, candidate key, and primary key. So if you remember all
Composite
those,
key.
yes, of course, composite key as
Yes.
well. And yes, in the coming time, in the coming slide, we have also the composite key as well, of course. So subset key of subset K of the R is a super key of the R if or in any legal relation. So what do you mean by the legal relation? It is a valid relation. So what is small r? Small r is the small. What is a small r? Yes, please. It is underlined. Just please tell me what do you
So
mean by
it's a
that.
valid relation over super key.
Okay, this is a good point. You are on the absolute right track. So we have the valid relation over the super key. So I repeat my statement once again. Let R be the relation schema. A subset K is a super key, or K is a key of the R is a super key of the relation R. If in any legal relation that is small r, in some bracket we are putting the R, means we are talking about the legal relations. On that is a valid relation of all pair T1 and T2. So now what is the T1, T2? That is tuples. Now tuples we have already seen into the practical way or in the specific manner in the mathematically way through the relational tuple calculus and relational algebra. We have already discussed about the tuples as well. So now it is clear to all about the tuples. So we will not touch that part again. So in all pair the T1 and T2 of the tuples in relation are such that T1 should not be equal to T2, and T1 of the K primary key which is consisted by the tuple T1 is not equal to tuple T2 followed by the same primary key, and that is no two tuples in any legal relation R may have the same value on attribute set K. So how you can say? Yes, please. Yes, is it clear to all, or is anyone having any doubt over here? Because the mathematical notation is written over here in symbolic way. No two tuples, no two tuples in any relation may have the same value on the attribute set K. Here I'm just explaining by the example. Then you can say in the relation student, you can see. Just let me go this part. In this relation you can say if we are talking about the two tuples Rohit or this Rohit Nath and the Rohit, suppose. So Rohit and we have the same value. This is the first relation, and we have the second tuple. Okay, if you're talking about the this tuple T1, this tuple T2, and followed by the some attribute key. But if you are not having the key attribute followed by the key, then duplicacy will be. So at the time T1 will be equal to the T1 will be equal to the T2, because we have the duplicacy, but we are having the key attribute definitely the, then at the time two relation will not be same. So how you can differentiate? Of course, by putting the student number. So if you are putting the student roll number, so all the details by the student name or student course, student phone number may be duplicated. There's no problem, but how you can differentiate? Of course, by putting the key attributes. Same thing we have over here. So here it means the tuple T1 is not equal to T2, but keep in mind the relation there will be no relation between the tuple T1 and T2, but and they should not be equal to if we are having the key. If we don't have the key at the time, the T1 and T2 will be equal, or maybe equal, not will be, it may be equal, because two different tuple can have the same value. So at the time we have a redundancy. So if we need to go through the functional dependency concept ahead, so we need to keep in mind the two tuples should not keep the same value. So this is the point. Yes, is it clear to all? So how you can do how you can differentiate? Of course, you are putting the key. So here in our relation student relation, what we can insert, or we can insert the student number, your name, your age, your phone number, your address, your city, your or course or your faculty name may same, but your identity, your friend identity will be different if your friend having the same information as it is, like name, age, date of birth, and so on so details. So how you can differentiate? Only the your roll number, your endowment number. So that's why we can say your entire information in form of the tuple and your friend's entire detail in the form of the tuple will be different. So this is the point. Yes, from this point, if it clear, if it this point is clear to all? Yes, please let me know, because this is the most important concept. From this most of the important concept, we will switch to the next part. So I divided by all the concept from the slide by slide in a specific manner. So here I need the answer from your side, yes or no, before jumping to the next slide. Yes, please tell me any doubt over here.
No, sir.
So the statement which is written here into the mathematical notation way, is it clear to all? T1 tuple and T2 tuple could not be equal. If you're having, then duplicacy we are having. Okay, so for the applying the functional dependency, it should not be. Okay, so we will come. Yes,
Yes,
please
sir,
tell.
clear, sir. We
Clear.
can
Okay.
move.
Okay, thank you. So the notion of the functional dependency generalize the notion of the super key. Let alpha is a subset of the R and beta is a subset of R. Now, what is alpha and what is the beta? Yes, please tell me what is the alpha and what is the beta. Yes, I need the
Sir,
answer.
super key, sir, alpha and beta super key.
Super key and super key will be always applied on the attributes. So alpha and beta can be two attributes. Can we say?
Yes, sir, we can say.
Okay. So we can say alpha and beta are the our two attributes. So alpha and beta are the two our attributes. So the functional dependency notion can be like this: alpha determinant to beta. If you are reading from this point arrow from left to right, then will use the term determinant. Okay, now determinant. And if you are reading this arrow from right to left, okay, right to left means I'm you are this, then
Depend.
is it is known as the dependence. So depend upon your reading points. Okay, this depend on the reading point, but always please keep in mind you have to use always arrow from left to right. You can't use the arrow like this one. So this arrow is not applicable, but it will be read by as if it will be read by as a dependent. So I can speak like alpha is determinant to beta, but beta is depend on the alpha. So while speaking anything, while understanding the thing, you have to keep in mind properly. So this dependency hold the relation R. Of course, in our relation R, these two attributes alpha and beta will be the part of the our relation R. So in any legal relation R, if I'm writing into the mathematical notation like small r is like this one. So for all the pairs of the tuple T1 and T2 in relation R will be and such that T1, okay. So the tuple which belong to the alpha attribute and the tuple which belong to the alpha T2 tuple which belong to the alpha 2 can be equal, because both are the same relation. So they will be equal, and it is also case that is a in this also case the T1 tuple T1 of the beta attribute will be equal to the tuple T2 of the beta attribute. So this is a condition will be true, of course, without any doubt. But dependency will be notion by the like this statement. Yes. Any doubt over here? Now keep in mind alpha such that the relation R and beta such that the relation R we have to think, because which is a part of the relation R. So alpha and beta such that both part would be the relation R. So these are the attributes. Yes. Tell me now. Any doubt over here?
सर क्लियर ढंग से नहीं हुआ, कोई टेबल से बता दो या फिर उसको थोड़ा वापस बता दो.
Just okay. I'm just moving to the my table. This one. See, in this relation student R. So if what is the attribute? I'm taking the name attribute. Okay. If I'm taking the name attribute T1, that is tuple T1. Okay. So I'm taking name attribute that is uh, name. Okay. So this is my point. So all the values that is tuple T1. So Rohit will be the same as it. If I'm putting the same attribute like name, and I'm putting the same next tuple that is 2, and that could be equal. That could be equal. So Rohit and could be equal. But when it could be equal, it depends on the dependency. If they are depend on the each other. So how to represent that alpha is determinant to the beta. So here alpha will be the name, or here anything just like the measure.
Alpha will be phone number. Alpha will be phone number dependent on name
Yeah,
Rohit.
yeah,
Beta.
you can take this term. Yes. Okay, now you can take this term. This is from T1 and T2. So here we have the two relation. One is a two sorry T1 and T2, and here we have the measure and phone number. So alpha will be your name, and beta could be phone number. Suppose that we have. So at the time, the both information will be equal. So
Yes
if
sir, समझ
if,
गया.
if we are taking the T1 or T2, both at the time both will be equal. So this is the point.
Okay sir, got it.
So this was the point I was on. This point. This point. Yes, we have seen this point. We have seen this point or same value. Okay. Yes, we were on that part. So at the time, both will equal. So okay, for example purpose, I can take name and phone number. So we have the same example, and so with the help of the example, we can take. So this name will be just like a alpha, and phone number will be like a beta. Okay. So this is the point. So we can say name determinant to the phone number, and phone number is depend on the name. So here we have seen the this example. So this is a dependency diagram we can see from this diagram, and from our previous diagram, and this concept which is written over here should be clear to all. Now is it clear to all right now? Tell me.
Yes sir, clear sir, we can move.
Okay, good. Using the functional dependency notion, we say that K is a super key of the relation R if K is determinant to the R, that is K is a super key of the of if super key if whenever T1K is equal to T2K. So of course, so we can say the primary any key just like student number we are having. So tuple what we have that should be equal, but keep in mind keep in mind the relation what value we have that should be equal to. So in this case, so we can say the T1 can be equal to T2. So functional dependency will allow us to express a constant that we cannot express using super key. So in the super key, there is no guarantee what we have. In the super key, you can say uniqueness will not be applicable. Okay, but in the primary key, always you have to use always you have to use the value into the uniqueness. So there's no guarantee in the super key or candidate key what value we have, or if we have the set of the value, or we have the domain. There's no duplicacy, but in the primary key we can't say there will be no duplicacy. So this point, the last point, you can say the functional dependency allow us to express constraint that we can't express using the super key. So super key does not represent your entire tuples value in form of the unique way. So okay, so it will does not have the unique. So to avoid the such thing, we have the primary key. So primary key will have the unique. So this is the point we need to keep in mind. So name and your phone number, anything could be the key by which you can say the I have the unique I have the single record or simple record. But there is no guarantee we have the duplicacy. There may be duplicacy, and if you have the duplicacy, so you can't say in the functional dependency your functional dependency does not belong to constraint, but it should be. So far we have seen the our information or table or data without the student number. So in the coming slide, we will see all these points, but let me clear to all once again. Functional dependency we are thinking. So in this diagram, it is also not mentioned about anything about the student number, student ID, and so and so. So we have the two different attributes, three different attributes, and from those attributes we can say if we are thinking if we have the key that is k, which is a part of the relation r, so of course in our relation r, name, phone number, major could be any key. So tuple which belong to the those key, that could be one tuple, two tuple, three tuples, just like t1, t2, like this one. So t1 or t2, so there may be some chance t1 tuple will be equal to the t2 tuple followed by the all those key. So we can say at the time the tuple t1 and t2 will be same, just like this one. You can see, just I'm moving to the my diagram once again, just see here. So just like this one, so it can have the redundancy of the data. So again, while functional dependency, measuring the functional dependency or providing the functional dependency, it is found that we have the duplicacy of record. So mathematically, if we need to found how to found a duplicacy or redundancy of the data, so functional dependency is the most important part. So this is only the layout by which we can see, but
सर जो
mathematically.
अभी हमने सर जो अभी हमने ये दो कंडीशंस पढ़ी सुपर की के ऊपर, तो
हम्म,
अगर वो कंडीशन ट्रू है मतलब रिडंडेंसी है डेटा में।
रिडंडेंसी है, क्योंकि आपका सुपर की कोई गारंटी नहीं देता कि आपके डेटा में डुप्लीकेसी नहीं होगी। सुपर की क्या होती है कि सिंपल ये होती है कि हमने कोई एट्रीब्यूट लिया और ये हम मान के चलते हैं कि उसके बेस में हमारे जो रिकॉर्ड है वो इन्फॉर्मेशन कंटेन करेगा। यू कैन टेक लाइक द प्रोफेसर, यू कैन कंटेन लाइक द ग्रेड और एनी कोर्स, बट it can have the duplicacy, its domain can have the set of the value or inform the duplicacy, but there is no guarantee we have the uniqueness. But if we are putting this we are taking this concept as a key, so it should have, but there is no guarantee. So that's why we have the primary key. So in our actual relation and the or a physical relation, talking about the relation physical schema, we will implement the primary key, but we will never implement the candidate key and super key, because the record may duplicacy inconsistency we can have. So to avoid the such things, so we have to use the primary key. So primary key just provide the uniqueness, provide the uniqueness, or we can say the distinct record, as well as the it does not follow, it does not belong to the null XP. So it can't
सर
store. Yes.
एक डाउट सर,
Hmm.
सुपर की एंड कंपोजिट की क्या होता है? कपल ऑफ कंपोजिट की कपल ऑफ प्राइमरी कीज होता है, और सुपर की जो होता है कि जितनी भी प्राइमरी कीज बन सकती है हमारी टेबल में हम उन सबको कपल करके बोलते हैं कि ये सुपर की। जैसे फोन, रजिस्ट्रेशन नंबर, आधार कार्ड, ये सब जो है वो
नहीं नहीं
डिफरेंशिएट कर सकते हैं डेटा का, तो हम इन सबके जॉइंट को सुपर की बोल देते हैं। तो आप ये कैसे बोल रहे हैं अपन की सुपर की से हम रिडंडेंसी फाइंड नहीं कर सकते? वो तो एकदम सुपर सेट हो गया।
नहीं नहीं, सुपर की एक्चुअली नहीं नहीं, वो वर्ड सुपर की है, लेकिन सुपर की क्या है कि ना, एक्चुअली सुपर की इज ड्राइव फ्रॉम द कैंडिडेट की. Okay, so first key we have the super key, then candidate key and the primary key, if you remember the such PPT.
यस सर।
Super key basically is determined that is we have the some attribute and which will, and we assume that, or we keep in mind the such attribute will maintain the all the domain value inform the uniqueness, but there's no guarantee, because it can have the duplicates, it may have, but there's no guarantee. So we will inspire such thing from the candidate key, and next we have the primary key. So before moving the primary key, let us need to look about the candidate key and then think about the super key. And when talking about the composite key is nothing which is a combination of two different attributes, and why which we can represent, just like the student phone number, a student name, that could be the composite key. So at the time we
सर
can say,
कंपोजिट की सुपर कीज की जो सबसेट होता है, जैसे सुपर कीज हमारे पास चार है तो उसके दो ले लिया तो वो कंपोजिट की हो गया।
एक सिंपल सी बात है, अगर आपका नाम है और आपका नाम है, आपका नाम एक्स वाई जेड है, और जरूरी नहीं है कि वो एक नेम के जो एट्रीब्यूट्स हैं उसमें आपका नाम अकेला ऐसा हो कि यूनिक हो। आप जैसे 10 नाम हो सकते हैं, एक्स वाई जेड कॉमन हो सकते हैं, देन हाउ टू डिफरेंशिएट सच थिंग, सो वी विल से अनदर एट्रीब्यूट
तो,
एंड दैट इज
तो
फोन
इस
नंबर।
चीज को इस
जस्ट
चीज
वन
को हम
सेकेंड।
काउंट ही नहीं करेंगे सुपर की में, अगर दो तीन नाम सेम जैसे हो रहे हैं तो?
सेम नाम तो नहीं होगा ना, नहीं होगा, तो इसी यही तो बात कह रहे हैं, यही तो पॉइंट है ना, आई एम जस्ट कमिंग ऑन दैट पॉइंट। यही तो पॉइंट है कि अगर मैं की लेके चल रहा हूँ, सुपर की है, तो अगर टपल टी वन लेके चल रहा हूँ, टपल टी टू लेके चल रहा हूँ, तो यहाँ गारंटी है कि हो सकता है कि दोनों टपल की वैल्यू एज इट इज हो। दोनों टपल की वैल्यू एज इट इज हो, जस्ट लाइक योर नेम। सो मैंने नेम लेके चला या मैंने आपकी एज लेके चला, तो एक वैल्यू ऐसी आएगी 20, ये 23 आपकी एज है 23, एक वैल्यूज भी आ गई दूसरे टपल की। तो उस समय दोनों टपल की जो वैल्यू हो सकती है वो सेम हो सकती है और पूरी इन्फॉर्मेशन सेम हो सकती है। सो हियर वी हैव टू नीड द कांस्टेंट, दिस इज द माय पॉइंट। The functional dependency need the constant. Here we are talking about the functional dependency without the constant. So we have, this is a point. तो और इम्पोर्टेंट बात ये है कि अगर नाम एक्स वाई जेड 10 नाम आ रहे हैं तो मुझे डिफरेंशिएट करना है, तो मैं क्या काम करूंगा, मैं रोल नंबर की बात ही नहीं कर रहा ना एनरोलमेंट नंबर। सो आई विल यूज द फोन नंबर। Okay, before taking the admission in any university or any college or any places, you did not get your registration number. Then how I can identify you are the my record or not? So I will take your phone number. So I will use a composite key. And how can I make the composite key? Simple, your name plus your phone number. So why which I can identify? Okay, yeah, okay, I'm talking about the Harshit, or I'm talking about the XYZ student, but he has this number. If I'm talking about the Harshit and who belong to the another city, but how I can identify? You will deny, sir, I'm not speaking the such Harshit, I'm speaking another Harshit. So I'm saying to you, my dear, I have your contact number. You are speaking the same Harshit. So this is the point. So composite key will be have. So super key will super key. Super key is not a basically combination of all those key. Super key is a weak key. We define that we have the something, and that can make the record for the uniqueness purpose, but there's no guarantee. So that's why we have the drawback in the super key. If you remember the such thing, I have shared such thing into my PPT as well. There was a drawback into super key and candidate key. So that's why the primary key was introduced at the time. This is a point we have seen.
Yes, sir.
So this is the point. So that's why we can say the T1 tuple and T2 tuple will be equal. But this is a drawback. If we have two tuples, we are having the same type. So dependency, due to this dependency, we have the duplicacy. This shows that we have the duplicacy. So after performing a little bit operations, we found that we have the duplicacy in our relation. Duplicates. Okay. So we have the duplicate record. So we can say we need the normalization. So this is the problem. Okay, yes, please. Now can I move to the my next slide for moving to the my next concept? Or of course it's part of the functional dependency. So in the so far functional dependency, what we have seen that is what is mean by the functional dependency and how to represent the functional dependency, and how to determine it or how to give it notation. So we have this notation, and if we are having the super key, and if super key is belong to the both tuple, so there may be some chance we have. Now you are not reading this point, since we are talking about this point, so it is also the case that when the both belong to the in the relation t1 t2 are equal. So in this case t1 and t2 tuple both will be the same at a time, and it shows that we have the duplicate record, just like the Rohit and phone number and its major component part. So at the time the different thing is required, that is a constraint. So constraint is a more important part. So if it, like we are talking about right now the attributes, so we have seen the different attributes like name, codes, and professor grade, and measure and phone number, other details. But you can't say we have the unique record because duplicacies exist, inconsistency we have having. So this is the point. Yes, please tell me now. Shall I explain this slide, or you have any doubt?
No doubt, sir.
So far we have discussed something about the functional dependencies. It is a summary of the such part over here. Now you can see or you can read out over here the functional dependency is uh, a relationship between the two attributes, typically between the pk. Of course, now we have the word over here that is between the pk and other non-key attributes. So okay, non-key attributes. Non-key attributes means we have an attribute like name. Name will be the always non-key attribute because your name is like xyz, and your friend also belong to same name. So it means your name can't have the key. S- but it can treat it as a candidate key only. Okay, it can treat it as a candidate key only, but just simple. Now one thing I want to tell you, the in the tricky way, in any relation, in any relation any attribute belong to itself as a key, and that key is known as the candidate key. So individual attribute always recognized as a simple key, and it is also known as the candidate key, and candidate key can have the duplicacy. This is the problem. So that's why the primary key were introduced at the time. So I'm coming on my point. A functional dependency is a relationship between the two attributes, typically between the pk and the other non-key attributes within a table. So what is a pk? Suppose I have the pk student id. Okay, and non-key, it could be anything like a age, name. Okay, and within table. So for any relation R, attribute by is functionally dependent on the attribute. So X usually the PK. So you have to keep in mind what this is a point X. X is what? This is an attribute. If every valid instance of the X, that value of the X uniquely determined. Now here we have the word uniquely, and so far we have not discussed this point unique word. Now we have introduced a unique word. So determine the value of the y. This relation will indicate the y. The relation represent the X determinant y. It means y value that is depend on the X. So we can say student ID. Yeah, student ID or student roll number is determined into the student name. So the student name who belong to the XYZ is depend on the student ID. So we can say now we have the same student name, but they have the same student name, but they have the different registration number,
Different student ID.
different student ID. So this is the point. So this introduce for the uniqueness in your relation, but we are not putting any constant. We are not putting any uh, primary key like constraint. Then there may be some chance your tuple, your record may have the duplicacy. So you can keep in mind the important point. As I told you, the left side of the functional dependency diagram. This is a notation, so we can treat it as a diagram purpose. So functional dependency diagram is called the determinant. So left side what we have SID. So it is known as a determinant, and an S name is right side. So we have the dependent. Okay, this is the summary I have told you already previously. In the previous slide I told you more detail. Now dependent and determinant. So in the functional dependency you have to use a word determinant and dependent properly. So I can read this statement in two way. X is determinant to y and y is dependent on the x. Okay, we are having the same sense just like the active sentence and passive sentences. So depend on the your reading from which direction you are reading your statement. X determined into y on y depend on the x, they have the same sense. Now this slide is clear to all? Yes, please tell me any doubt over here.
No doubt, sir.
So this little bit idea about the functional dependency is clear to all. Why functional dependency is required? Because with the functional dependency we can try to normalize something to find the duplicacy record, and or to avoid a duplicacy record. If you did not found a duplicity of the record, then how you can normalize? So for justification purpose under the normalization, we need to see important aspect, that is we have the duplicate record or not. So this functional dependency will help you to find a duplicacy in your table. So that's why the function dependency is required. So this is the normalization prerequisites important term. Now, is it clear to all about right now?
Yes, sir, clear.
Okay, good. So here we have an example as I told you. So functional, we have the multiple now. So student identity we have the, suppose SIN is determine the SIN, that is student identification, is determine the name, address and birth date. The student name and address and the birth date may same, like your birth date could be equal to your friend and your friend name is also equal to your name, and maybe both belong to the same city. So at the time the these three different attributes are having the same value, but we need to provide the uniqueness, then student ID or student IIN, identification number. So given ISN number we can determine any of the any of the other attribute within the table, like this one. Okay, so date completion. So how can you can identify, how you can identify? We have the composition of the or composition composite attribute. So that is a student number, student identification number, student ID or course, in which course student is registered. So date completion. So when he or she complete his or her degree, So date completion could be the any attribute like it contains the some year of completion or year of passing. Like the year date completion means year of passing, year of passing. Okay. So year of passing is an attribute which is depend on the student ID and the course, in which course the student was registered and how to identify the student ID. So this could be the point we have the student ID in course. It is known as a composite PK or composite ID. Now another we have the ISBN. ISBN what? ISBN is the unique number or unique number for the book. That is okay. So this unique number by which we can identify, but title of the any book could be same, like Introduction to Python. We have found the 1,000 books, but how to identify in among the 1,000 book which one belong to the R class? So we have given the some ISBN number. Okay, go for this ISBN number and we will see this ISBN number. We found the Introduction to Python and this is written by the author such as XXY. So this is the point we can say. Here we have the again part. So ISBN is determinant to title and title depend on the ISBN. So this is the point. So here we have the some example. And here SIN and course is also known as the composite key, and this composite key determine the primary key. So if you want to make the primary key along with the both attributes, so we can have, so at the time this is known as a composite key. So we have this point because this will be always unique, and course may have the duplicate, course may have the many same record. So along with this part, along with the primary key with the candidate key, just I can say like this key is a primary key and this is the candidate key. I'm writing CK. So we are making the composite key. So again this is a good example we have. Yes, please tell me now, any doubt here in this example? Yes, student, please tell me now, any doubt? Okay. So rules of the functional dependency I will tell you tomorrow or next class. So this is the just idea about the functional dependency introduction and prerequisites parts, and more detail about the function dependency I will tell you next class. Okay. So from this point I'm just I need to ask the important question. If you have really any problem, then you can ask me.